Welcome, Matt Taylor here with a specialist maths tutorial. Today I'm doing questions 8 through 11, the multi-choice section for chapter 2.5, which is about polar form, modulus, and argument of complex numbers. Question 8 asks, the polar coordinates of the point -2 and 2 are, and the options are there. So to convert from this form to polar form, you need to use two formulas, one to find r, which is this part, and one to find the argument, which is the angle. And that's what I've done here. So to find r, you use Pythagoras because when you draw the 2 points out on a graph, you can make a triangle with the base and the height and all that stuff. And Pythagoras gives you r because r in a complex number is the distance from the origin to the point. So use Pythagoras, and the other one is the angle that between like the origin and the point is what you need. So you have to inverse tan because you've got the opposite and adjacent sides. So this is what you get when you do both of them. You have to the coordinates in the second quadrant, like with this angle here is -pi/4, which is negative 45 degrees for those who don't know, and that would be not correct because that does give you a tan value of -1, but that's not the angle of the coordinate. Because if you put a coordinate -2 across on the x and 2 up on the y to get, because the angle is measured anti-clockwise from the origin, so it has to go all the way 135 degrees from 0 degrees to get to the angle. So that's why it's 3π/4. So that makes the answer E. So question 9 asks, in Cartesian form, 2 cis -π/3 is equal to, and these are the options. So it's like this question but in the opposite. So there are formulas for getting from this form, form I should say, to this form, and then there's this form to that form, and basically it's just like reverse. But what you need to do is that the formulas to find the x coordinate is r times cos of theta, and y equals r times cos of, that should say sine, sorry, that should say r sine theta. Yeah, sorry about that, but I did use sine here. It's basically also, again, because of the triangle, the way it's set up, that's how you get the answers. So 1 take 3i is the complex coordinate. So that would be this one, C. 10. If z equals -√3/2 take half I, then the argument of z is equal to. So for this one, you have to use the second part of this, which is the tan of y on x, and this is the y and this is the x in the coordinate. So you go like this, and again it's like in question 8 where you have to move the coordinate because it doesn't fit where the equation lies. So it has to be -5π/6. It can't be π/6 because that would give you a different point on the graph, and that's not what it's asking for. It has to be -5π/6. So that makes the answer A. And for 11, it's really simple. If z equals r cis theta, then the conjugate of z is equal to. So what happens with the conjugate is the I value becomes negative, so it's basically reflected in the x-axis. So to reflect a graph in the x-axis that's in this form, so r chooses how far away from the origin it is, and theta is how many degrees counterclockwise it is from the origin. So to flip it in the x-axis, all you need to do is make the angle negative, so C, because that will flip the graph from, say it was like 1 cis π/4. So if it was 1 cis -π/4, it would be flipped in the x-axis. So yeah, hopefully that helps. That's how to do all those questions. Thanks for watching. Bye.